Ooh. All right, checking levels. Mike, we're good. Hello, welcome back. Another week, another hacking session. Let's see. Today we're going to be working on Tigerbeetle. I've got it working, sort of, mostly. Wild story. But the last time we worked on the Tigerbeetle client for Haskell, I don't know if you were there for it, but if you weren't, Tigerbeetle's a financial database, a financial transactions database, the financial transactions database that it wants to be. Pretty cool. It's written in a language called Zig, and the way they want developers to build clients for this library is to link to a shared object library that's kind of like a C library, almost effectively. A C library, okay? So instead of like making your client speak the protocol, you speak this library, and this client library will take care of a lot of the low-level protocol details for you. You just send it some data and fetch some data back asynchronously from it. Now, what was interesting about this is that the way, well, we got a relink error. Okay, so on the stream a while ago when I was working on this, we kind of reached a roadblock because we got to a relink error. And I spent quite a bit of time debugging this, trying to figure this out, because linker errors they're not super user-friendly, let's say. So it turns out a relink error was being thrown, and I went into figuring that out, and I was debugging the GHC Cabal build process, trying to understand what exactly the GCC command being issued by GHC when it's linking this library into our executable that we're building in Haskell, what's going on there. Because I thought maybe libraries like maybe compiled a certain way, like in kind of an odd way, and that if we built a static Haskell executable, we would maybe bypass whatever this relink issue was going on, like as a dynamic linking kind of error. Because we only got it at runtime instead of compile time. So I was like, okay. And thanks to some helpful folks who understand the GHC build tools, I was able to figure out what these actual GHC command being, or GCC flags being emitted by GHC were, by passing in some extra options. I could probably write this all out on a blog so I don't forget. But once I got that going, I could create a minimal Nix environment that could demonstrate the problem. And I narrowed it down basically to a link ordering issue. Okay. So when you're linking together object files to build a library or an executable, right, these things in the ELF format have like a header that tells the system reading that binary data, because it's all binary data when it gets compiled down to the machine goes up. Tells it where different symbols are, some configuration for like dynamic linking and stuff, things like that. And depending on the order in which the linker finds libraries at runtime. So there's a runtime linker too in Linux. And we were getting this linker error because if the linker looks for a certain symbol and defined by the thing it's trying to build, and then it loads another library in that also has that symbol defined in its object file. So in the Tigerbeetle client object file, there's a kind of a naming conflict, and it's like, what implementation do I use? And the relink error is basically telling the user, hey, this thing you're trying to link to your executable already has a symbol that I already have. You need to relink it against that library that I already have. relink. So that was cool. Like I could reproduce it with a very small C program and link order options. And I created an issue upstream in the Tigerbeetle code base to bring this all together. So that was on GitHub. Tigerbeetle / Tigerbeetle. Yeah, it got closed. Which I'll get into in the part 2 of the story. Okay. So this is the C program. When you compile with -lm, the link argument to link libm at the end of the options, it executes fine because this library doesn't explicitly say it depends on that, on libm. And so the runtime linker goes, oh, okay, I'm going to use this one. It's fine. So we get a success. And then if you compile the link with the arguments reversed, then we get the error. That's the relink error. It turns out that the fix for this has to do with the way Zig's build tools work. Oh, and Joe is reopening it here. So, anyways, before we get to that part, because I haven't actually read that part, so Zig's build tools have, I guess they have their own vendored versions of libc for the different platforms in the build tools dependency tree somewhere. And we were looking through the Zig build tools code to figure out why we couldn't add an explicit step to add that -lm flag for Tigerbeetles into Tigerbeetle's build.zig file when compiling Tigerbeetle to fix this kind of upstream. And it turns out that the build tools will detect that you've loaded one of the libc libraries, and it'll just say link -lc, not libm specifically, like -lm. And it only does that once. So even if you add explicitly an option in its build.zig file to link libm, like please link this, it won't. It just links libc and just thinks that's all you want. So it was kind of disappointing there was no real fix for that. We spent quite a bit of time trying to figure out a patch that would work. So we ended up having to use some Nix utils, one of them called patch elf, to literally change the elf headers in the compiled object file from Tigerbeetle's official C client to update what's called the rpath file there, so that the object file says I depend on libm's implementation of the function that it was throwing the relink error on, the symbols it was throwing the relink error for. So like that was a whole adventure, but the patch elf approach works. So now we're able to move ahead with the library. We can link it dynamically, which is nice. We don't have to go through the whole pain of trying to build a static Haskell executable. And we don't have to force users of this client library to do that either. I think that was going to be a bit of a bummer, I think. Like forcing users of the library to be like, well, if you want to use this library and you want to talk to Tigerbeetle from Haskell, you're going to have to statically link your executable. I think that would have turned off a fair number of projects. Anyways, this issue did get closed by Matt Clad, Tigerbeetle developer, because I think they're intending to actually like not depend on libc at all for anything, which of course would resolve the issue, right? Our executable would still depend on libm and libc and everything, but this library, if it doesn't use anything in libc, then that should be fine, right? But let's get into this. I haven't read this yet. Jake Hatchmar says, I think this issue should be reopened. As far as I can tell, there's no way to avoid the libc dependency on Linux, possibly ever. If you use TLS and aren't using the Zig toolchain for linking, which feels like one of the more common use cases for this library. Michael says, there's no fundamental need to use libc, so we should spend the effort making libc-less possible, rather than adding workarounds for using libc. There's at least two possible paths forward. We do not, in fact, use TLS, so spawning TLS-less thread is an option. We could leave thread spawning to the user of the library. Interesting. So make connection handling. Our issue. I don't know how I feel about that yet. I just read that, so that's going to take a little bit to digest to understand the implications there. So Tigerbeetle client itself doesn't use TLS. And then leave thread. I'm not sure what that means. So leave thread spawning to the user library. Oh, okay. Yeah. So one of the things that you get from depending on libc is like p-threads and multi-threading. And I think there's another issue that was linked here. Yeah. Where they discuss a little bit about this in the Tigerbeetle land. Yeah. TLS image. This workaround in, upstream, even upstream in Zig itself. Maybe in this one. Maybe not. But somewhere in there, someone was like, hey, we still kind of need to be able to link this stuff to be able to be packaged as libraries upstream in other Linux distributions that ship libc. So I don't know how that's going to shake out in the long term. Hopefully for this library it won't matter too much. But I could see it being a bigger thing maybe for them to figure out. But in the meantime, let's get to the code. I just thought that would be an interesting story. It was kind of a great feeling to finally get through that linker error and just get that out of the way so we can actually work on this library now and not be messing around with that stuff. As fun as learning about linking and ABIs and stuff is. Yeah, so I guess there is some consequence to knowing this stuff, because if you're looking to link to other Zig libraries from Haskell code, you might need to be aware of that, because it can be maybe perhaps a bit challenging. Oh, and this, and then I can get that up. Okay, so other things we need to do before we can get started is review this code. So now that this has been unblocked, Jonathan and I and other contributors have been able to like really start going full steam ahead on this. So we've been working on the library quite a lot. This PR adds a minimal raw client function. Okay, cool. So the way we're trying to build out the library is that we have like the FFI modules. These literally just marshal C types between the library and the C library on the Tigerbeetle side and Haskell, our side. And on top of that FFI layer, because the FFI code is not great to work with directly, we have a bunch of modules in the raw namespace. We're calling it raw, the raw layer, and that's going to take care of like allocating structs and filling them in from arguments from like client code, and then passing them to the FFI layer and making the calls with the FFI layer. A similar structure to how other C libraries and C using libraries in the Haskell ecosystem work, like SDL2. So nothing terribly novel there. So this one updates client, changes here, this record, TB packet, okay. Just some namespace changes there. Okay, I think vector is... Oh, okay, they probably just changed the type of the way it's imported. Yeah, okay. Don't need to qualify it, cool. Add the foreign function calls to this module, client.hsc for DNNing the client. Client submit, that'll be important for sending packets to the C library, the C client, and once it's initialized. So that's how we define client completion context. Client completion context. And, okay. Yeah. Client completion context, all that stuff. Cool. So raw account, I had to make some changes because they've changed some of the structures used in the C library headers. It's still an early project, so that's probably going to be changing a fair bit before it becomes stable. So create accounts. Okay, that changed because the enums changed. Cool. Import TB packet here in client. And then raw queue. Okay, these may not be necessary, but Figure decides to give hooks into the different client lifecycle states. With client operations on init failure. So some callbacks. Use submit. Okay. Client kind, echo, or standard. Okay. Okay, so then we get this with client function that takes a kind, cluster ID, a text, with client ops. Okay, that's a structure containing these callbacks and a completion callback, and does some stuff in IO. Okay, I gotta change this music. This is not my jam. There we go, better. Finally. Yeah, so we gotta free all your stuff. Okay. Yes. I think this is mergeable. I'm not sure how this is gonna fit in with the higher level layer. I guess we'll have to see. Because the stuff we added there on the client level, we have a transformer that includes resource T that does resource cleanup and handling. So this might fit into that, where it would allocate and call this stuff in the IO layer for you, and if there's any kind of exception during that process, yeah, we could still clean up. I think that's pretty good. As long as all it's really doing is just submitting our packet and doing the FFI layer operations for us, that's good. Read client. That's good. Okay. Commenting out this. Honestly, we don't need to leave commented in out code in, but otherwise good. Kind of want to work on this part of the code tonight, so I'm willing to merge that. We'll clean that up as we go. It's good. Let's approve. Try it out. Super duper. Okay. So I'll show you what I'm talking about with the high level stuff, and then hopefully that'll get merged pretty quickly. Now we can start integrating the two maybe. If not, I would also like to work on how we're going to test everything. I want to be able to make sure that the high-level code is testable without having to do integration, even though we're going to have integration tests for the library, obviously. But just so on an isolation level, on a unit level, I want to be able to test individual bits of the library without having to like fire everything up and do a bunch of I/O and stuff. So it's nice and fast and easy. Yeah. Let's fetch. Okay, so the high-level stuff is in source, database, Tigerbeetle. And this is what mostly users of the library will be interacting with and calling. You'll get a nice Haskell-y interface, and then we translate all of that down into the FFI layer through the FFI stuff and call the C library. So this is our high-level type, client monad here. It's got the base monad M. It's probably going to be I/O, right? Some state T on top of that. So there's going to be some client state that needs to be kept track of when doing these calls. Except T after the state T. So basically we're doing like state actions where transforming the state could introduce logic errors, so except T catches those, and we'll throw those for you. And resource T on top of all of that, so that will handle any of the raw level calls that we need to make. We can wrap them in resource T and make sure that everything gets cleaned up. All right. So then the account stuff that I want to get working first is kind of like the first call we're going to try to make into the Tigerbeetle database from Haskell to create an account. So this is all written in terms of client at the moment. It doesn't actually 100% work yet because I need to be able to submit a packet, and that comes from the PR we just reviewed, not removed. Okay. And I thought there was another function I had in there for somewhere in client, maybe. I guess not. Okay. Yeah. Okay. So some other things I want to check out, actually, is Tigerbeetle docs. Okay. So a request queries or updates the database state. That's what we want to try and do, but from Haskell. So a request consists of one or more events of the same type sent to the cluster in a single message. For example, a single request Can create multiple transfers, but cannot both create accounts and transfers. Fair enough. The cluster commits an entire request at once. All right, so it's matching what we're looking at in the code right now for account, for example. You can create a batch of accounts. Events are applied in series such that successive events observe the effects of previous ones, and event timestamps are totally ordered. Each request receives one reply message from the cluster. The reply contains one result for each event in the request. Oh, this actually might simplify the client code. Yeah, maybe not, but I wonder if that means like we get one synchronous result message from the server in the client code. Because anyways, before I was looking at some of the implementation of this, and it looked like we would get, when we make a request, we send a packet with our data, and then we get like asynchronously, and we have a callback that we have to pass it, and the callback contains the response events. And I was fairly certain there might be like more than one, perhaps. But if it sends back just one, that's pretty cool. So events that create objects are idempotent. The first event to create an object with a given ID will receive the OK result. Subsequent events that attempt to create the same object will receive the exists result. Okay. So to achieve high throughput, Tigerbeetle amortizes the overhead of consensus and I/O by batching many events in each request. So in the default configuration, the maximum batch sizes for each request type are this. So we probably actually should bake this into the library too. Right, we can do this validation and these assertions on this list here. And respect these limits at compile time rather than waiting until runtime to realize it. Oh. In fact, I'm going to make an issue for that in the project. Respect request batch size limits. The library should be able to validate these. Either by types or assertions. I think that's reasonable. We should be able to do something like that. Cool. So yeah, guarantees. Our request executes within the cluster at most once. Requests do not time out. Okay, clients will continuously retry requests until they receive a reply from the cluster. This is because in the case of a network partition, a lack of response from the cluster could either indicate that the request was dropped before it was processed, or that the reply was dropped after the request was processed. Okay, yeah. Note that individual pending transfers within a request may have timeouts. Okay. And they're idempotent, so retrying should be fine. You'll just get the exists. But transfers maybe. Okay, different result. Requests retried by their original client session receive identical replies. Requests retried by a different client Same request body, different session, may receive different replies. Events within a request are executed in sequence. The effects of a given event are observable when the next event then the request is applied. Events within a request do not interleave with events from other requests. Right, so there's claiming that processing is serializable and atomic. All events within a request batch are committed, or none are. Note that this does not mean that all of the events in a batch will succeed, or that all will fail. Events succeed or fail independently unless they are explicitly linked. So this is more just about processing, not whether the individual events actually apply or not. Once committed, an event will always be committed. The cluster's state never backtracks. Within a cluster, object timestamps are unique and strictly increasing. No two objects within the same cluster will have the same timestamp. Furthermore, the order of timestamps indicates the order in which the objects were committed. Okay, cool. Yeah. Okay, that's just some recommendations about architecture. But okay, so we need to focus on this stuff. Okay, did that merge? Because I'll be happy to merge it. For example, create accounts. Let's do the create accounts. Oh, copy the HTML. I was afraid it would. What was the number? 8,190. It looks like it was merged. Good, good. Oh, we have another one. Interface with a TB async model. Okay, TB account. Oh, and pop. Oh, we got all the stuff with the queries too. Cool, cool. And transfers. Okay. Raw account, raw client. Okay. Oh, and all right. Jeez, quick, quick! These are coming quick. Holy smokes! Yeah, it looks good to me. Okay, let's pull those in. Okay, we proved no marshalling and that one. Okay. Cool. All right. So, chat. I lost you there for a second. Just checking in with you. Make sure everybody's good. Any questions? No? Okay, cool. If you do have any questions about what I'm doing or what I'm working on, feel free to jump in there and just ask away. It's all good. Okay, let's create a branch from master. We're gonna call it improvement. Integrate raw client. Okay, so my goal here is going to be to get a runner function in our high-level client monad to call our low-level or raw layer client. So all the stuff that we've been reviewing and merging. Although, oh, that might be coming in the change that we're just looking at. I think that might be in queue still at the moment, but it looks like it's going to get all moved. Query, yeah, transfer, yeah, account, yeah, raw client. It's going to be all this stuff now, yeah. Okay, we're getting rid of queue. Okay, yes, I want this merged. Are we done with it? Hopefully we're done with it. Okay, but for now, it's in the queue module. Okay, oof. Friend, we need to turn on your white space cleanup function, or we need to automate cleaning up white space for RPRs. Okay. Yeah, so we need to call this from here. We need a runner function that calls into that. Right, so with client here is going to be our entry point into the library. It's going to probably need to take your the configuration details about your Tigerbeetle instance. So a couple of arguments like your address, cluster address. What else do we need to start up? Tigerbeetle init client, init a client. I guess it's already in queue. Let me look here. We need a cluster ID, an address, and probably about it. I think the high level of it is going to take care of the completion callback and filling all that in into the state and giving that back to you. But this stuff still has to come from the users. So, do we have a type for that already? Client cluster ID. That's a low level, I think. Yeah, that's an FFI type, so we'll call it cluster We'll still call it cluster idea here. Cluster address. Maybe we generate cluster ID. I don't know. And I think that's all we need. So we're going to go client M of A. Now we're going to need some context here for that M type at least. And that's going to need monad IO, which is going to imply monad there so that we know that we can do IO operations on it at some level. We might not even need that. Putting it in there. Okay, so we're going to need to import some things from the raw layer. So I got Haskell cat in my lap tonight, so if I'm extra bad at typing, it's her fault. Haskell cat enjoys my lap a lot. Yeah, database. Tigerbeetle. Raw. And I think we have post position qualified on this project. Let's get our builder going. Oh, I don't have... We're not using stack on this one. I think we have GHCID in this Nix environment. So we'll use that. Cool. Okay, so we don't have type, we don't have cluster ID in scope. Maybe it might help if my Haskell process type was set to Cabal REPL. And then if we do process reload, it'll die. Why did it die? Okay, it's not running the shell in the right environment, blah, blah, blah. Ugh. Okay, one of the things I really don't like about Nix, and I know it's there for reasons, the reason why is it works this way and all that, but the shell stuff, like setting up environments by manipulating shells, is super annoying because it doesn't really work with all my Emacs tooling super well. There's probably a way to make it work, but, and I'm just being dumb by not figuring it out, but I don't want to figure it's a lot to do. There's probably a way to do it though. I probably should just spend some time on it because I'm getting to use it more and more. Anyhoozle, enough complaining there. So I can't get that necessarily working there. So cluster ID is not in scope. We need a type for that. Let's get that type going. I just want to make sure. Oh no, what did I do with you, chat? Sorry. Gotta bust you out again. Okay, there we go. So let's do that. We'll go here. Just put cluster ID for now. I don't know what type it's actually going to be, but that's fine. Just make cluster ID like this. Very simple. We similarly don't have one for cluster address. I'll make it an actual type at some point, but right now I'm just going to make it a type alias. Let's gasp a string. Ugh. Okay, now what do we get? TB account flags. No instance for num. In raw account on line 31. Okay. Okay, that's true. That was recently changed, I think, to set. In the FFI layer, I think. Internal FFI account. Yep, here, account flags. Okay. That's not, no. We shouldn't have the set here. Right, this shouldn't be a set. This should still be match the C type. Whatever the C type is, which I think is just a word 16 probably, or a word 8. To set those flags. There should be a higher level type of the raw layer that could do this. And translate it into the set, so I think that code has to move. But in order to fix this, we just need empty there. I'm gonna leave a note there. Okay. What else did I modify here? Oh, my Emacs is cleaning up all the white space as it goes. That's what's happening. Oops. Okay, so there's just a little bit of white space there. Changes. Okay, so we added the comment there. Okay, so I'm going to create a little commit with those separately from everything else. Okay, here we're good. Okay. Okay, so once we have those in scope, we want to be able to call the raw code. For now is under Q, unless that's been merged, and then I can update this to use that. Not yet. I don't want to merge it right now and just mess with Jonathan. He's still working on the PR, but it'll be, hopefully the types won't change. It'll just be changing the imports. Okay, so then in here, do ignore those arguments for now. So we're going to call with client. Actually, what are we going to call this with? With client ops. So use submit. It's going to take a function from TB packet to IO TB client status. And that's going to return us an IO action. That's not going to be useful at this layer because we're not going to be able to investigate or inspect the TB client status that gets returned here from that callback. If anything, that should be TB client status, and this also returns TB client status. Or else, with client, does it. This is just TB packet to IO unit, or just plain TB packet to IO unit, or just plain TB packet to something. I don't know. Doesn't even really matter. But with client returns that, because at this level, we can't do anything but call this. And the client, the user of the library isn't supposed to be calling into the raw layer in order to submit packets and stuff. Like, we're supposed to be using that library in here. So it's okay if it returns results and stuff. It shouldn't be retaining any internal state or anything like that. All right, so run client. This code is making completion callback in its status, and then finally calling run client here, and then making sure that we free the client pointer, which is good. Okay, and then in its status. So this code, run client gets the client pointer and checks. Oh, and gets the TB init status. See, because we call init status here. Okay, and so this pattern matches on the init status and then submits our packet. Okay, yeah, this is doing too much. No, we should be doing this code over here on the left is what should be doing that stuff. It should just be calling into raw to do like raw init. Right, so it should be calling into raw to do this, and then it should be calling raw again to run the client. The submit packet call. And then our resource T type in the monad transformer here will take care of initializing, deinitializing, and allocating and making sure that everything gets cleaned up with foreign library. Yeah. So let me see if we can merge that. Because I want to do that. I have to message some folks. Cool. Got some chat going on about it right now. Can I merge that client PR? Just want to get that working with client monad. Okay, it sounds like yes. Okay, cool. It sounds like we can. So I'll go ahead and get that going. Okay, he's gonna merge it. Cool, because we kind of need that. Super duper. Okay, so while we wait for that, ultimately what I want to be able to write here with client is to, yeah, get that init status here by calling into the raw layer and like raw dot init client. And we pass in our cluster ID. We can pull those in scope now, I guess. And then the client here should probably be doing the pattern match on the status of the client. Pretty much the same code there. But all the what the raw layer will do is just hide like allocating the pointer and maybe stuff. But it's okay if the raw stuff sends us back data about like the operation we asked it to do, right? I want to be able to write that. Cool. So we're merged. Let's go get that code. I'll just stash this. Okay, pull that in. We'll integrate raw branch and merge master in there. Get failed. Conflicts. Okay, no problem. How did we get a... Oh, the white space changes. Oops. Marshall TP count result. Oh, okay, that just adds the instance. Yeah, okay. There. That. So this one. Yeah. Fix this one. Bow. Yeah, we're gonna... Sure, we'll take that one. Okay, mark the merge complete, commit it. Which one's not? What are you talking about? Oh, get why. Oh, I have unstaged changes in queue. You know what? I'm gonna abort that. Yep. Nothing there. Everything's stashed and clean. My index is fine. It's immaculate. Merge master, please. Reread it from disk. Sure. Yes. Mark it as resolved. Yes. Okay, next. Boom. Yeah. Yes. Everything's good. Okay. Commit it. What the F? Let's look at Q. Why is this file still here? The problem is the file's still there? Is that what you're saying? You know what? This branch isn't very long-lived anyway. Let's abort this and just create a new branch. Okay, yeah. Integrate raw client. Okay, that's fine. Apply that stash. We're good. Ugh. Ugh. Oh, no, wrong one. Yeah, that's the white space changes. Beep, 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 beep. When applied, this will clean up a white space in raw client. Yep. Okay, so the raw client call just has to call init client. And the result of init client, what do we get in the C code? If we look at the tbclient.h file. So for example, if we init echo here, all right, we get a status back, but we have to pass in, let's see, client out. That's the TB client T. The cluster ID, the address pointer, the length of that address pointer, the completion context, and the callback that we want to pass in. This and its status is an enumeration that just tells us, like, did the client initialize properly? Is everything good? I'm ready to go. Right. Initializes the new Tigerbeetle client, which connects to the address provided and completes the submitted packets by invoking the callback with the given context. Okay, so when we init one of these, it completes the submitted packets by invoking the callback with the given context. Right, so we give it a completion context. And then this callback at some point later on gets another packet back from the server and tells you what happened. Or gives you the result packet, so you know you can read the result packet back out. So, and I think from the documentation, this can't time out. No, this is the request. So I'm assuming request here means actually like the client submit, but maybe it also includes the client init. All right, we init the client. It was successful. We submit a packet. The callback eventually gets the data from the server that's sent back, the response, right? We match that response back to the client we knitted with, because that's going to happen at a later time, right? Asynchronously. So the raw, all we need to do with the raw layer is call init and return the init status to the higher level client. What the high level client's going to do, right, is going to pass in this completion callback, and then when that callback calls back, right, in the Haskell code, on the Haskell side, it's going to update the state in the client monad and add the response packet into the state. Oh, Jonathan's got another PR, but I don't think he's aware of what we're trying to do here. Okay, let's look at the suggestion though. Okay, not too far off. Change it to an either TB init status instead of IO unit. And when this change? Client handle to IOA. Yeah, I think we'll hold off a little bit on that until we get a little bit further with this. But yeah, so every time we submit a request, I think we got to init the client, pass in this completion context parameter with the callback. The callback needs to, once it's called back, update the state in the client monad, matching the completion context so that it matches the response back to the original request. And then we can punt that back to the user. So it's almost like with client here also needs to have, not just in the client M monads, return some value of type A, but needs that callback, what to do with the response value. Right, because we get the response value asynchronously, and well, if this is monad state, you could let's model that out. So we have this completion context counter, and then we would need a something like a response map or a request map. It's not a very good name. Response map. It's like, what even is a response map? I don't know. But we would need data.map.script. I don't know if we need the library yet, but this would be a map from int, a completion context, to a packet or a response, which comes in a TB packet. At a higher level, we want to have like a nicer response type here, not a packet necessarily. So we can put a dummy type in there, like response. Map the completion context request to the response. Or probably better, map the request to the response by the completion context. Right, and I guess the kind of like shape of this, I'm thinking, would be, what would it look like? The kind of code I want to write, right? Is like with client, I give you my cluster ID, I give you my address. And I want to call things like create account with my create account parameters. Whatever they would be, like ID1, initial balance, something like this. I already have that kind of mapped out. I'm just sketching here. ID2, for example. Alright, starting balance is 0. Alright. And this code run by itself should make one call to the TV client API, right, to create those accounts. Now, what's with client going to return to us? Like, is it a result like this? So we can bind the result? Or, because the other thing we could do is, like, we could add another create accounts call here. Right, in this monad, like, that would be fine. And what does this mean? What does this program do? Right, it should do this once, get the result, then do this, get the result. But then how do we know that everything we did inside this client program worked? And so maybe it's like more like results, or we just call back again. All right, so you give us a callback with callback. All right, and what the monad will do now is it will, every action you define in here in this little block, right, create accounts, will call into the library, do all this stuff, create accounts. It will get a result back if it succeeded, and it'll call your callback with the result. And then your callback can do whatever it needs to do. And then the second line will be create accounts, right? And it'll do it again as well. All right, and then you could write a little program like create accounts, like that, and then you could be like create transfer, whatever source account to something or other, where the transfer arguments are, right? You could query account, ID1 with some query, whatever. Right, you can do those things, and the library will just take care of calling the TV client code for you, calling the library, which calls out to the database, and blah, blah, blah. And then your callback just handles the results. Right, and so this code here would manage all of that. I think that's pretty good. That feels pretty good. Because Otherwise, we have to do it piecemeal at a time. Right, we do, or we bind results. But if we bind results, right, what ends up happening is like each of these actions is asynchronous, essentially. And we have to await all of them when we bind, right? So we await this one, we await this one, then we get our results, and then the rest of our other outer program can like continue on. That makes sense? So I think the callback method is probably better. This would allow you to spawn off with client in a thread with your program here if you wanted to do something dynamic and continuously. And then do whatever you need to do with the responses in the callback, or we could provide a callback API, but we could also provide like an STM kind of API. Where instead of calling back to you synchronously after each response comes back, you give us a channel to communicate with you. All right, and so this program would mean that we create accounts and we create a transfer or create transfers, whatever. It's probably batch, so we create transfers, etc. and so forth. And then each of these actions, their responses will be pushed to the channel or the bounded queue or whatever you want, whatever we decide to put in there. Right, and that way, we could communicate back with you over a channel like that. Right, but we don't want the raw layer to retain control of that setup. I think that's more of a high-level concern of how to orchestrate the calls and like what these programs mean. So that's, I'm gonna comment that out, create region as well, and that's what we should do here. So we call with client. Let's do the callback one. That one's pretty chill, pretty easy. So you press your callback here, which will give the response, and some IO like monad. Unit? We don't really need anything back from the callback. We're just giving you the response, so you can do whatever you want with it. And then it happens within client. Yeah. Right, and then, because ultimately we're going to have create accounts. Right, it's going to be that list of create account parameters. Oh, we already have that function. Yeah, that makes sense. Yeah, and then we need a run function for our monad to run the actual client monad. Run everything. That probably should be named getClient. I like getClient. And let's just add that here. That'd be like run client. Maybe a little bit general about it, and We take client M of A, return an IO of A, or M of A. Yeah, so that would be like run client with client. Kind of like it just with client. That's not so bad. Right, because then we go like this, run client. Oh, yeah, we need the initial state. Oh, then with client would probably actually do something. Anyways, you need to pass in the client state because with a state T there. And it'd be like exec state T. You always have to flip the arguments around on that one. And it's getting late on the stream. It's been a while since I had to like build a minor transformer and do a runner function. We got to peel off state T first by running exec state. So are we going to want eval? Well, state T, which is a result type. Yeah, so maybe like eval state T. Now that takes the discarding the final state, just return the final value. In this case, it would be unit, right? But it takes the state computation first, and then the argument as the initial value. So flip this over here. No. That. That. Then after evaluating the state, we run accept T, and then resource T is the one I'm probably has something similar. But I don't know that library very well. Something like that. Let's get GHCID running. It'll tell me what I'm doing wrong. Okay, good. Okay. What do we got here? Some issues with raw client. On 136. TE isn't imported. Okay, do we have that in the Cabal file? Text, yeah, okay. Okay, this needs to be cleaned up. Beta.text. Coding, I believe it is. And 43. Yeah, we need pure unit. Here. Big is not in scope. Okay, we're just gonna comment this out. Because we'll probably use parts of it. We just need to break it up a little bit. Okay, client. Okay, I don't know what the type of response is going to look like yet. Let's put a dummy one in there. Okay, right, exactly. So we don't have init client yet. So let's go make sure we have init client on the raw level in client. Client pointer, init fn. Nothing named init fn in here. Does that come from the FFI layer maybe? No, just TV, client, init. Okay, the raw layer just needs to orchestrate calling this function here for us and giving us the status back. Okay, oh, okay, that's why it needs the pointer though, because TV client gets filled in by the C code. Makes sense. Okay, so the init client then at the raw level wouldn't just return the result, it would also have to return the TV client. could make it a tuple. TB init status and TB client. Although it would probably be maybe TB client, because depending on the TB init status, we may or may not actually have a client. So I believe we have success, we have unexpected, we have out of memory, address invalid, address limit exceeded, system resource, so anything but success. I imagine we're not actually we're gonna get a null pointer there. So we shouldn't dereference it. So even at this raw layer, like, I wonder if we should return the status and maybe TB client, or if the return type of init client here should just be the TB client. You can expect that means success, and otherwise we'll throw an IO exception. Right, it's at the raw layer, that should be allowed. And at the higher level client layer, we have resource T, so if something does get we can allocate and we can ask to run this function init client and deallocate the pointer if we don't get the result we're looking for. So I think it's fair for the raw layer to do that kind of stuff. You want out, Haskell kitty? There you go. Go to your pillow. She has a nice little Haskell bed beside me. It's not actually Haskell, it's just a pillow. But yeah, you know. She likes to be nearby. Okay, so let's do that then. We'll get the stuff we need to call init with. Right, so it does need the pointer to the TB client. We need the cluster ID. We need the address pointer. That's a string, the address string. What was just text? Okay. And completion context. Let's uint pointer. And the callback. So I think we have type alias for yeah, this stuff, yeah, okay, yeah, this is not, yeah, exactly. This is what the high-level library, the high-level part of the library should be managing. We don't need to be managing this down here at the raw layer. I see what Jonathan's going there for there though. Yeah, something like this. But not managed in IO, managed in our nice client monad. For the most part. Okay, so Where were we? The callback type. Transfer query client. TB completion callback. There we go. Okay, cool, cool. Like that, and this will happen in IO and return TB init status. No, the TB client. So return the TB client on the TB init success. Results from the server, or response from the server. Throws a IO exception. The error result. Otherwise. All right, and then the resource T will handle that. Cleaning up the TB client pointer and all that stuff that gets passed into init client. Now that means that users who are trying to use this library, trying to connect to it, are going to get IO exceptions in this case. So that might not be super nice. But what else? I mean, what else are you going to do if you can't init the client, right? In the failure case. I guess you could programmatically catch it and retry the connection a bunch of times. So maybe we actually do want to do that. So maybe it should be that. I just don't like the dependent pair there in this API. So if we were like, hey, let's try this init result type. The only time TB client is going to be just something is when the value of this TB init status is success. Otherwise it's false. And like, that's yeah. So, I mean, another way we could model it though is an either, like in the PR that we just looked at. Either some error case or the TB client. That actually feels a little bit better. That gives you a chance at least to inspect the value of the error case, see what's going on. Some of those init responses though, like out of memory and stuff, like your Haskell program is probably going to crash soon if that's the case. If it hasn't already. So I don't know. I feel like an IO error or an IO exception is appropriate in that case, that you can't connect. But I do like the ability to catch and retry some of those cases you might need to, so that's probably better. So in that case, let's go with that. Either init error or TB client. Call it client init error. And that'll basically be an enum of the error cases in that enumeration. So let's go client init. This is getting too wrapped around. Let's bring it back. Client init error like that. Okay, so then the higher level code. Oh, uint pointer. Oh, what was that? There. Foreign.pointer. Just forgot the name of it again. Function pointer. No, it's maybe it's a int pointer. Int pointer, word pointer. Yeah, so I think it's a uint pointer there, so it's word pointer we want there. This. Okay, I want this function to exist. So that the higher level the client library can then call init status with those bits. Cluster ID, cluster address, a word pointer. I'll have to initialize one here, probably. And TB completion callback. Okay. And call it completion context. I think that's the completion context when we call with client here is going to pull a new one out of the state. Or no, it actually, each of these actions is going to have to come on. All right, like when we write a program like this with client, this create accounts is going to need its own completion context in order to get the response and map the response back to this particular request. Because those are gathered asynchronously, they're not synchronous. Same with create transfer. So create accounts calls, create accounts needs to get its completion context. We increment that counter inside the client state. Then create transfer calls. It does the same thing, right? And query account is also going to have to do the same thing. All right, so every time we call one of these, the client's going to have to the monad state, the monad's internal state's going to have to update somehow. So it's almost like init status here, when we initialize the client, is going to initialize for each action. You know? So, I'm gonna have to figure out how to model that. But I am running out of overtime here tonight, so I'm gonna have to put this one on the drawing board. And clean it up later. Let's see, just to do a quick review. Yeah, and then I will mark this as a work in progress commit to the branch, and I guess I can push the branch up maybe. Lockout. Client, monad, runner. Okay. And then I'm just going to leave myself a little documentation actually for that. No, that's pretty decent. I think I'll understand that, but I'm just going to add a little bit of comment here. For each action in the computation, the TV client request to the TV client. And when the callback completes with the response, the monad calls the user's callback. With the response. And in this case, we want each action to submit the response to the SDN mounted queue channel, whatever. What else do we need to remember about this? Each action will need to update the client monad state to map responses. Actually, I'll just put that on the following line. I'll paste that here. Okay. We'll release it interactively here, squash that in. Okay, push that up. So, that's the end of the stream. That's all the time I got for today. I'm excited for this library. I'm so stoked. I think it's going to be great. And I can't wait to get to that black triangle moment where we can actually, like, make one of these requests from a Haskell REPL to a running Tigerbeetle client. I think we're really, really close. Just got to settle out this interface here and how that's going to execute and how the programs are going to look. I kind of like this API. I think it looks pretty good. We'll see how that hashes out. I'm going to propose that, and we'll discuss it and figure out what the ultimate form of this is going to take. And yeah, maybe next week we will see that actually happen. And then it's a matter of just filling out the other methods in the client monad there, and we'll have this nice high-level library to work with. And and a build. So this is really cool. I think Tigerbeetle is neat. The development team behind it has some interesting ideas. We just saw on some of the tickets that we were looking at the beginning that they have some interesting issues about how software should be constructed and shipped. They're trying to go libc-less in this, so that's going to be neat to see how they pull that off and what that will mean for client library authors such as ourselves and their build tool chains, because the way it's packaged right now does interfere with build tool chains, unfortunately, but maybe that will be alleviated if they succeed in that. So we'll see how that plays out. And yeah, all the code that you've seen here tonight that we've been working on lives on GitHub. I'm Agent Ultra, and this is Tigerbeetle HS. The repository's here. All right, so you can paste that there. You can follow along, follow if you like, if you're interested, and checking it out. Yeah, you can. I do these streams once a week, so if you want, like and subscribe if you're following on my YouTube channel and following my VODs there, or follow here on Twitch and set up your notifications so you'll get notified when I do these streams. Otherwise, you can write it down in your calendar. I do them on Wednesday evenings now at about 10 after 8 in the Eastern time zone. So hopefully we'll see you next week, and you can check out the action then and see how well we do. Go to the link above my head. If you have some time, check it out. It's declarative.tv. They have a lot of cool streamers doing stuff in Erlang and Haskell and other sort of declarative-ish languages and functional languages and all kinds of stuff there. They also have a Discord server that has a channel for this stream. So if you didn't get a chance to ask a question on the stream, or you just want to chat with other like-minded folks, I highly recommend checking out that Discord server. The more the merrier. So again, may all your monads be free and your types always check, and we'll see you next week. Take care out there, happy hacking, and all the best.